Go over the double arrow out rule, and then we're going to go over the first set of practice problems. The double arrow out rule is actually pretty easy compared to some of the other rules we've been learning, like the tilde in, tilde out rule, arrow in rule. And if you remember what I said about the double arrow is, say, we have this written here. The double arrow is actually the same as saying one conditional statement and then the other conditional statement. So really the double arrow is not a necessary feature of natural deduction because we can write it out like this, but we include it in our rules, so I guess we can sort of reduce it down to a single operator rather than writing the conjunction each time. But why I say this is because our double arrow out rule is to say if we have a double arrow, then we can write either of the conditional statements from it. So it's a really easy rule. Let's just look at, say, our first arrow out rule proof that we did. So say if we had something like this, it would be a rather easy proof. We would have P double arrow Q as an assumption, P as an assumption. Then what we would do in line 3 is just write one of the conditional statements, usually one double arrow out, and then we can toss our antecedent into our conditional statement to get our consequent from 2 and 3, arrow out. That's as easy as it gets, because double arrow, like I said, is just both of the arrows together. So if we wanted, we could change these around. Let's just do some erasing. So say if I gave you Q, I told you to prove P. So we have Q as an assumption now. Now we would do the same exact thing, doing double arrow out, and then tossing the Q into our Q arrow P to get P. So the thing about the double arrow is it says you have both of these conjunctions wrapped up into one statement, or not conjunctions, each one of these conditionals wrapped up into one statement, so you can just eliminate one of the sides of the arrow by writing one of the conditionals. So let's do some practice problems to see what this looks like. Here in the first problem, we have three premises. We have P double arrow Q, we got P double arrow S, we got Q, we're looking to prove S. So when we're looking to prove like an S here in this statement, or here in this problem, we just need to eliminate the biconditionals into regular conditionals, and then we can get everything out. So if you remember our chain rule, where we were trying to build or try to get a single consequent out of a chain of conditionals, that's sort of the same thing that's going on here. So if we take the first biconditional and we do Q arrow P, so one double arrow out, we're eliminating one of the arrows in the first premise. Then we can toss our antecedent into that to get P. So that's going to be from 3 and 4, arrow out, 1 and 3. Then we can take our second premise and we could do P arrow S, doing 2 double arrow out, and then we can toss our antecedent into that from 5 and 6, arrow out, and that's how we prove this one. It looks just like a chain rule. It looks like if we had this, which is just to say we would take this, put it into here, put this into here, and get to here. But the only steps we need to make are breaking down our biconditionals into the premises that we would need here and here to do the chain rule. So that is the first problem that we've got. Let me erase this so you can just see it as it is proved. And there's the first one. Here, looking at our conclusion, we've got an R and a Q. So that tells us we need to find R by itself, Q by itself, and then put them together with and introduction. So let's look at what we've got. We've got a biconditional, so that means I can write the arrow either way. I've got a regular conditional in 2. Can't do anything with that because I don't have the antecedent, and then I just have a single letter by itself. So, not much to do. We don't really need to make an assumption here. So, we can break down our double arrow in 1 and do this, though. So that's going to be from 1. And now we've got the antecedent for 1. We can get P and Q from 3 and 4. Arrow out. 1 and 3. Now, I said I needed Q. So why don't I get Q out by itself, doing 5 and out. And then I can get P out by itself, doing the same rule. And I'll use that P for my conditional statement in 2 to get R. So that's going to be from 2 is where my conditional statement is. P is in 7. And I'm doing arrow out. So that's 1, 2, and 3. And now I've got R. So I can just do P. Oops, nope. Gotta write the right thing. I want to write R and Q. And that's going to be from 6 and 8. And in 6 and 8. 1, 2, and 3. Don't need that 10 there. So, again, I've told you before on instances in which it seems like you can't do anything, you'd make a PA of the opposite of the conclusion and look for a contradiction and then build a tilde in or a tilde out from that. But with this new rule, we can do something with our premises, which is break this down into the double arrows. And we just chose to do the one version of it. We could have also written this using our one double arrow out, but it wouldn't have been useful because we didn't have P and Q. But just knowing the rule, you could have done it. But that is the second problem. Now this one is pretty short, because looking at our conclusions, it's just S by itself. We can get to S if we can get this biconditional out, and then get the antecedent for it. So let's look at what we've got. Well, we've got a Q. We might be able to build the antecedent if P or Q is our antecedent to our biconditional. So let's write that first. So let's write our conditional statement from 1. Oops, not and. 1, double arrow out. 1. Now we can build our antecedent for our conditional in line 3 by doing P or Q. 2, wedge in. And then we can toss that into our conditional statement to get S and T from 3 and 4. Arrow out. 3 and 4 have 1 and 2. And then we just need to do and out on 5. And that is our conclusion that we were looking for. So that is problem 3. Now we're going to make these a little bit more challenging. Let's look at our conclusion. Our conclusion, the main operator here, is an arrow. So if you remember from our conditional in, our arrow in, whenever you see a conditional as the conclusion, you want to assume the antecedent and look to prove the consequent. So we're looking to prove this Q and P. And to prove Q and P, we need Q by itself and P by itself. But first things first, we need to assume the left side of the conditional as a PA and look to prove the consequent And so now we've got T. And we've got a similar situation as before. We can take our biconditional in line 1, and we can write it like that. Now we can build the antecedent for that using our T by doing S or T from 2 wedge in. We can toss that into our conditional statement to get P and Q. So that's going to be 3 and 4, arrow out, and 2. And now what are we looking for? We're looking for Q and P. We've got P and Q, so we just need to separate them. And then put them back together the way we need them in our conclusion. And then now we assumed our antecedent in line 2. We got to the consequent that we were looking to derive. So from 2, 8, arrow in. And if you remember, I hope you do, that whenever we do arrow in, just like with tilde in or tilde out, we get rid of our PA assumption, and it just moves down to just 1 by itself. There we go. So that's problem 4. So this one is a little bit involved. You may not know immediately. You're looking at the conclusion, it's a Q by itself, and you're like, am I supposed to assume it's opposite here? We see Q by itself here in the biconditional statement in line 1, so we might be able to get it without doing a tilde out in our proof. So let's try to see how far we can get. If we don't get there, then we know that we need to assume the opposite of Q, look for a contradiction, and work from there. So we can break up our biconditional statement. And looking at it, we could write it as T or S, arrow P or Q, P arrow Q. That would be from 1, double arrow out. We could also write P arrow Q, T or S from 1, double arrow out. Both of those work. I'm going to keep them both here. We're not going to need both of them, obviously, but just showing you that you can write both of them, because we would look at the antecedents. Which one of these can we actually make? Could we make P arrow Q from what we've got? Well, we would have to assume P and then derive Q by itself. We couldn't do that because that's not anywhere in our proof. It's attached to this conditional statement. We would need to find a different way to get to P arrow Q before we could even think about tossing it into that conditional statement. Could we build our T or S? Well, we've got a T by itself right here, and we could wedge in the S, so maybe that's the right route to go. So let's just go with that route. Let's separate the T and P from 2 and out. Then we can wedge in our S from 5, wedge in. We'll toss it into our line 3 to get P arrow Q. So 3 and 7, arrow out, 3 and 7, that's 1 and 2. Now we can toss our P into our P arrow Q, and look, we're going to get to our conclusion that we were looking to get to. We were looking to get to Q by itself. That's going to be from 6 and 8, arrow out, 1 and 2. There aren't any PAs. We don't have to worry about any of that. So we didn't end up using this line at all. We used all the other lines, but again, you can write it because it follows the rule for 1 double arrow out. But it was easy. We don't have to go back through and do a tilde in or tilde Q and try to do a tilde out. We just used the rules that we had, got to the conclusion. So here on this one, this is another instance in which we want to make sure we look at our conclusion, because what's the main operator in the conclusion? Well, it's the arrow. So we know we're going to assume its antecedent and then look to derive its consequence. So line 3, we're going to assume P as a PA, and we're going to look to prove Q. So what can we do with what we've got now? Well, we can toss this into the conditional statement to get Q double arrow T from 1 and 3, arrow out, 1 and 3. Now we can do our double arrow out rule. Remember, we can write T arrow Q, or we could write Q arrow T. Again, we're not going to need both of these, but I'll just write them both here. As you do more practice problems, it becomes more evident which one you will actually need and which one is not need or superfluous. But I'll just write them here because why not? So we've got both of these conditional statements. Do we have the antecedent to one of them? Well, we do. We've got the T up here. So we can toss it into line 5 to get Q. So that would be 2 and 5, arrow out, 1, 2, and 3. Now we've got to our consequent that we are looking to derive. It depends upon our PA, so we will take our PA and arrow in on our consequent, and that's from 1, 2, and 3, but remember that the 3 drops out because we're doing arrow in, and so that is number 6. Now on to number 7, let's look at our conclusion. Our conclusion is a tilde, so that should immediately tell you we're going to assume the opposite as a PA, and we're going to look to prove a contradiction. We're looking for something that doesn't seem to match, and then we'll tilde in on our PA. So we could do a couple of things first. Maybe the first thing we'll do is we'll separate this P and Q from 2. And that just breaks our letters down, but we can break our double arrow down into these if we really want. Again, we won't need both of them, but you can do it anyway. Which one do we actually have the antecedent for? Well, we have the antecedent for 5, so we can get tilde Q from 3, 5, arrow out, 1 and 2. And now we've got a contradiction we can build. We've got a Q in line 4. We've got a tilde Q in line 7. So we can do 4 and 7 and in. 4 and 7 are 1 and 2. And then we can tilde in on our PA. From 2 and 8. Tilde in 1 and 2. But remember, we do tilde in or tilde out or arrow in, we remove the PA and we just reduce it down to the other assumptions necessary. So that is problem 7. So here on 8, we have an ampersand as our main operator. So we know we need to prove tilde Q and tilde R, and then we'll put them together using our ampersand N. Now, because tilde Q and tilde R don't appear in our premises, that means we're going to have to do a tilde introduction on them. So this is going to be rather lengthy, but it's going to be the same process twice over. And to save myself a little bit of room, I'm going to start by getting the tilde S out, 1 using 1 ampersand out, and then I'm going to get this conditional statement out of 2 double arrow out. Because here's my S and here's my tilde S, I'm going to need to get to contradictions once I do my PAs for the tilde introduction, and I know that's where I'm going to get my contradiction from. There's nowhere else I can get a contradiction from. There's no tilde T. There's no, there's just simply nothing else because there's no tilde T. It's going to have to come from tilde S and S getting put together. So now with that, let's try and prove tilde Q by assuming its opposite as a PA. and then looking to prove contradiction. So we can wedge in the R on 5, doing wedge in, and then we can get our S out from 4 and 6, arrow out. That would be from 2 and 5. Now we got an S. We've got not S in line 3. So that's going to be that's going to be 3 and 7 and in. 3 and 7 is going to be 1, 2, and 5. So there's our contradiction. It depends upon our PA. So our PA is in 5. Our contradiction is in 8. We're doing tilde in. And that's going to be from 1, 2, and 5. But remember that we get rid of the PA that's associated with the tilde introduction. That would be the PA in 5. So we just have that. So there's one side of our conjunction that we're looking to prove. Just got to do the same exact thing now in line 10 by assuming the opposite of R. Then we can wedge in our Q. It's going to be 10. And then we can get our S from 4 and 11, arrow out. 4 and 11 have 2 and 5. And then we have S and not S from 3 and 12, ampersand in. That's going to be from 1, 2, and 5. Then we can tilde R because our PA is in 10 and our contradiction is in 13. That's going to be, oops, sorry. That got caught up in the previous one. There we go. So, where are we at? Need to do 1, 2, and 10, but the 10 will drop out because we're doing our tilde in. And then we just need to put them together. Tilde Q and tilde R from 9 and 14, ampersand in, 1 and 2. And 16 is not needed. So, as you can see, it's the same proof twice over from here to here. PA, wedge in, arrow out, ampersand in, tilde in. Wedge in, arrow out, ampersand in, tilde in. And then just put them both together at the very end. So just repeating the same thing twice, and then put them together once you have done both the same proofs for them. So that is problem 8. Here on 9, looking at our conclusion, it is a tilde. So we know, since we don't see a tilde P anywhere in our proof, we're going to have to assume the opposite of it, just like the last problem, and look to build a contradiction. So what we've got here, let's see, got a couple biconditionals. And we're looking for a contradiction. So we're looking for something in which we can have it written both ways, once in the positive, once in the negative. So gives us pretty good inclination here that we're going to need this one from line 1, and we're going to need this one from line 2, because those are the ones in which we have consequence that we could put together and make a contradiction. So that's going to be from 2 there. Now let's look at what we can do. For the conditional line 6, we've already got the T, so we could do 3 and 6, arrow out. 3 and 6 is 2 and 3. Then for 8, we still need our S. So can we build the antecedent line 5? Well, we can. By putting them together, we can do 3, 4, ampersand in, 3 and 4, 2, 3, 4, 3 and 4, 3 and 4. Oops, sorry, too much there. So 3 and 4 are going to be just 3 and 4. Now we can toss it into 1, or not 1, but in line 5, the conditional statement that we got from line 1's biconditional, and then we get S. So that's going to be from 5 and 8, arrow out, 5 and 8, that's 1, 3, 4. Now we can put the S and not S together, doing 7, 9, ampersand in, 1, 2, 3, and 4. Now we've got a contradiction, depends upon our PA, so we can tilde in on our PA, 4, 10, tilde in, 1, 2, 3. The 4 drops out because we're doing tilde in. So that is problem 9. Now for the final problem, our conclusion again is a tilde, and we see there is no tilde t in there, so we immediately know we're assuming t is a PA, and we're going to look at to prove a contradiction. So, what do we got? Well, there are a couple things that we could ultimately do here. We could probably first eliminate the ampersand here in line 1. That's a good start. So we can break it down. Now we got the double arrow as our main operator in 2. So we can write tilde Q, tilde P, double arrow T. Let's make that arrow a little bit more obvious. So that would come from 2, double arrow out. We could also write the other one. The only problem is the antecedent is a biconditional as the main operator. And not only do we sort of not have the information to build it, you also don't have the rule yet to build it. So we should already know that we're not going to need the other side of that biconditional, or the other conditional statement coming from the biconditional in line 2. So let's just stick with this one. If it happens to be the case that we need the other one, we'll go back and get it, but that seems very unlikely. So look at the conditional statement in line 6. Do we have its antecedent? Well, we do in 5. So we can get tilde P, double arrow T. From 5 and 6, arrow out. Then we've got another double arrow here. So remember that our goal is to get to a contradiction. Well, I've got a P here, and I've got a tilde P here, so maybe that is how I'm building my contradiction. Maybe I will just get the T arrow to P out from 7. And then I do have the antecedent for that conditional statement, so I can get tilde P from, looks like, 3 and 8, arrow out. That's going to be 2 and 3. Now I've got my contradiction that I can build from 4 and 9. Got a contradiction, depends upon my PA, so we can just tilde in on the PA. So that's going to be 3 and 10, tilde in, 1, 2, 3 ultimately drops out because we're doing the tilde in rule on our PA. So that is problem 10.